Good morning. This lesson is all about the circle. We're going to identify the characteristics of circles, recognize chords and diameters of circles, and recognize special relationships between radii and chords. So I'll start first with a little review on the parts of a circle. A circle is the set of all points in a plane that are equidistant from a given point, called the center. A circle is named by its center. So we have here circle M. A chord is a segment that has both of its endpoints on the circle. So I could draw in chord PQ. The diameter is a chord that passes through the center of the circle. It is the longest chord. So here I'll draw in my diameter and label it AB. So I have my diameter AB, and I have my chord PQ. But because my diameter has both of its endpoints on the circle, it's also a chord. A radius is a segment with one endpoint at the center of the circle and the other endpoint on the circle. A radius is half of the diameter. So I can draw my radius, MB. I can also draw another radius and call it MX. Continuing on with more definitions, we have concentric circles. These are two or more coplanar circles with the same center. So here in my picture here, if I label this center B, it's the same center for all of these circles. So how do we know if two circles are congruent? Well, if they have the same length radius, in circle S here, and I have circle P here, and if their radii are congruent, then the circles are congruent. However, if they are not congruent, then I know the circles are not congruent. Continuing on with the definitions, if we have a point that is inside or in the interior of a circle, its distance from the center is less than that of the radius. So if I have my circle M, that's the center of the circle. In the interior, if I have this point A in the interior, that distance from the center to point A is going to be less than the radius. If I have a point B that's outside of the circle, or in the exterior of the circle, then its distance from the center is going to be greater than the radius. And if I have a point C on the circle, then I know the distance from the center to that point is equal to the radius. Okay, sorry about that. I think I messed up on that part. At this point, you have some problems to do, some exercises to do on your worksheet, so I'd like you to pause the video at this point and complete exercises 1, 2, 3, and 4. Okay, now I'm going to talk about the relationships between the radius and the chord. The definition says that the distance from the center of a circle to a chord is the measure of the perpendicular segment from the center to the chord. So in this circle, circle P, I'll call it, and if we have this chord, chord AB, what the definition means is that the distance between this point P and the chord is going to be the perpendicular segment to the chord. So if I draw this in as best as I can, that distance, and if I label, let's just label this point right here, point M, the distance from P to AB would be the length of PM. The shortest distance is always the perpendicular distance. At this point, I would like you to work on exercise 5. You have the problem on your worksheet, and you will be asked to enter that answer into the program before continuing. Okay, next we have a theorem. If a radius is perpendicular to a chord, then it bisects the chord. So what I'm given is that I've got circle K, with chord MJ, and let's just label this here X. I'm going to be given that KX is perpendicular to MJ. My conclusion is that MX will be congruent to XJ. Now let's get ready for exercise 6. If we have AB, this is chord AB, AB is 30, and this is circle O, and OE is 8. Okay, E is this point of intersection. Find the radius of the circle. So go ahead and write this down in your notes, and you'll be pausing and entering your answer into the program before continuing. So make sure you have it written down. I forgot to tell you that OE is perpendicular to AB. Our next theorem states that if a radius of a circle bisects the chord, then it is perpendicular to that chord. Does this look familiar? Well, this is actually the converse of the previous theorem. So here what I'm saying is if I have circle B and chord AB, and I know that this radius here is bisecting the chord, then what the theorem is saying is that on this point, let's label this M. What this is saying is that BM, BM would be perpendicular to AB. So given that BM bisects AB, my conclusion would be that BM is perpendicular to AB. Now I'm going to let you try it. In this example, if we have circle O, and I know that, let's see, let's draw in my radius. So my radius OB, and I've got a chord EF. And I know that this is perpendicular. If OF equals 10 and EF equals 16, find the distance the chord is from the center. So in other words, you're finding OM. Take a second to write this down, and you'll be asked to pause and answer the question before continuing. Excellent, nice job. So here, let's just finish this up. Let me change my color. Let's go with orange. If I draw in my radius there, I know that OF is 10 and EF is 16. But because I know that OB is perpendicular to EF, I know that that radius bisects the chord. So if EF is 16, then I know each part here is 8. So now you see you have a right triangle, a hypotenuse is 10, and one of the legs is 8. So you can use the Pythagorean theorem to figure out the missing leg. And hopefully you came up with the answer of 6. Nice job. Our last theorem states that the perpendicular bisector of a chord passes through the center of the circle. So in this circle, we have chord XY. Let me draw this in. Okay. Let's see. We have a chord XY. And I'm going to draw in the perpendicular bisector to that chord. Okay. So remember, a perpendicular bisector is going to give us two congruent parts, and it's going to form this right angle. So what this theorem means is that the perpendicular bisector will eventually pass through the center of the circle. So here's my center, and it'll eventually pass through the center. Oops, I didn't draw that very well. But when you have a perpendicular bisector of a chord, you know that that perpendicular bisector will pass through the center of the circle. Now we have a few examples to work on, and I'll ask you to complete the examples on your own, and you'll be asked to enter your answer before continuing. When you continue, I'll work through the problem for you. So in this example, we have a radius of circle O is 13 millimeters. Okay. The radius goes from the center of the circle to a point on the circle. So I can draw in my radius, OP, and know that that is 13 millimeters. The length of the chord PQ is 10 millimeters. So this whole area, this whole length here is 10 millimeters. Oops. And I'm asked to find the distance from chord PQ to the center O. So when I draw that in, if I'm finding the distance, I know the distance is going to be the perpendicular to that chord. And this is what I'm asked to find. Well, if that perpendicular distance is drawn in, I know that it's going to bisect the chord. So these two pieces are congruent. If the whole entire length is 10, each one is 5. So at this point, I can use the Pythagorean theorem. X squared plus 5 squared is equal to 13 squared. In solving this, I find that x is equal to 12. So hopefully that's the answer you got. Now take a moment to complete the next example, and after entering your answer, I'll work the problem. So in this example, we're given circle O, and OE is perpendicular to CD. Therefore, I know it bisects this chord. If CD is 24, then I know each segment here is 12. And I'm given that the radius is 15. So I could draw the radius in on either side here. Doesn't matter which one, I only need one. But the radius is 15, and I'm asked to find OE. So again, using the Pythagorean theorem, I can calculate OE by writing x squared plus 12 squared is equal to 15 squared. So hopefully you got x equals 9. Nice job. Our next example, you're asked to find the radius of a circle if a 30 centimeter chord is 20 centimeters from the center. So here I was asked to find the radius. I know that it's a 30 centimeter chord, so that gives 15 on each side here. And it's 20 centimeters from the center. So this is my 20 right here. The answer here is 25. So now in this unit, we're going to be getting back to proofs. I've got 2 proofs to go through here. We'll see how I do on this little video. So the first statement here is that I have circle Q, and I know that PR is perpendicular to ST. So I'm going to write that down as my given, and I'm also going to go ahead and label it on the picture, because that helps me go through the proof. So I know that PR is perpendicular to ST. Okay, so my second statement would be that PR bisects ST. So since it's perpendicular, I can say that. Okay, PR bisects ST, because if a radius is perpendicular to a chord, it bisects the chord. And I'm going to go ahead and mark my picture, if I can. My next statement is that PR is a perpendicular bisector to ST. And this is the perpendicular bisector theorem. And then my final statement is that segment PS is congruent to PT, and that's what I was trying to prove. My reason is because if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints. And I know my writing is not so great, but I'm using my finger instead of a stylus because I don't have one, so hopefully you can read that. Again, this is my first attempt at making this video, or any video, so I hope it has worked out well for you. Okay, so our second proof. Here I actually had a mistake. We're trying to prove that circle P is congruent to circle Q. So let's go ahead and start this. We're going to start with the givens. I'm given that triangle ABC is isosceles. Therefore, AB is congruent to AC. And I'm given circle P and circle Q. So I know P and Q are the centers of those circles, and that BC is parallel to PQ. So I have to go ahead and mark my picture, which I think I forgot here. There we go. There we go. And I know that angle ABC is congruent to angle P, and angle ACB is congruent to angle Q. Because if I have parallel lines, then I know my corresponding angles are congruent. Therefore, I have angle ABC is congruent to angle ACB, because if I have those two congruent segments, then I know I have the congruent angles, my isosceles triangles. And therefore, I have angle P is congruent to angle Q. And this is going a little bit fast for me, but again, it's my first time doing this, so bear with me. So the transitive property gives me that angle P is congruent to angle Q. Then I have AP is congruent to AQ, because if I have two congruent angles of my isosceles triangle, then I know the sides are congruent. And from that I can say that PB is congruent to CQ, and that is the subtraction property. And because I know that PB is congruent to CQ, those are the radii of my circles, so I can say that circle P is congruent to circle Q. Now, don't worry if that went a little bit fast. We can always go over it at a later time. I was just kind of trying out my new video process here, and hopefully it worked well for you. At this point, you have homework. The homework is in the book, page 443 to 445, and those following numbers. So good luck, and I'll see you on Monday.